calculations for uh, the numbers which slashers managed pulse controller for the washing machine motor will do, depending on diameters, perimeters, RPMs, other things, right, which will vary. And I I made it all them in this piece of paper. I calculated what will come out if something like the slasher you have will be attached on the same shaft as the washing machine motor itself, and mm, the the slasher or the thing like a slasher should be powered with the 300 volts, right, which will feed the washing machine motor. And the thing is that it all has to be uh, um, timed properly. So I supposed like the slasher with 4 inches of diameter will have uh, 101 .6 millimeters, right? So if that you divide it into the each pulses an Anaheim motor will make to each magnet, because that video you showed, there are such divisions into the drum motor, right, as you were pointing each where the magnet changes of pole. So I counted, you had 4 for each stack of magnet, right? You had 4 points. So I supposed you had 4 times 12 stacks of magnets. That is 48 poles uh, of the magnets for each rotation, right? Each rotation has 48 poles. So I supposed, because the Anaheim controller, the sensors receive the signal each magnet which passes through them, right? So I thought the Anaheim controller was able to measure 48 poles in at those 1500 RPMs you achieved with it, right? So that was the maximum of the Anaheim controller, and that means those transistors the Anaheim controller has, I can kinda show you it. This has MOSFET in it. You can see them. They're behind the board. They are quite hidden. They are behind. Let me show you if I can. They are. Fuck the light. They are there. You see behind that stack. Let's say that is the front, right? You can see that, but behind this, there is something. That those are the MOSFET, and there are six MOSFET, because this not only manages the the output signal of the 3-phase by 3 MOSFET. It has 6. The other 3, I don't know what they do exactly. I'm not expert in electronics, but I understand 3 minimum were needed to run that with a board with electronics, right? Because that is the only sequencing apparatus. The component for a sequence is the transistor, is no other. right? Without transistor, you cannot sequence the signal or the current. Sorry, what the fuck. So what I found is like I supposed the Anaheim controller at 1500 RPMs, 1600 I counted, right? I took 48 poles from the, I remember you, the 48 poles from each rotation. So those 48 poles times the revolutions per minute you achieved are 76,800 pulses per minute that that controller was managing, and dividing that by 3 because there are 3 phases, right? Each phase was managing with the sensors on it, okay, to do 25,600 per phase and minute. That was the Anaheim's, I think. If it took in count the sensors, all the points you you write, you uh, you describe, right? I'm not sure if it if it only takes in account half of them, right? Let's say only north or only south. The calculation is just divided by 2 or something. I did it with counting all of them, so I have the highest numbers possible with the calculation I made. Okay, so what about the real construction of the controller making slashers? I think there is good points of it. Everything will be visible, okay? It will be, there will be no chipboard, no electronics, not something that everybody has seen, but most everybody doesn't know how it works. They only see the labyrinth, the maze of the the wiring or the shit, and nobody knows. But if the controller are just cylinders rotating with timing on them, like plastic is not connected, copper is connected, so everybody can understand that. It's just there is open and there is closed, and you can see it. And there is time because if you position them right across the cylinder, if you put 3 connections to it, it will give you the timing, right? Just like you wanted to do the 60 hertz. Just we have to change the numbers of connections. Instead having half the time of our rotation, there's the open gate of the slasher. Let's put it 8 times open. That's how I made it. I took into account the slasher had that 4 inches diameter and so the perimeter, and then calculating with the perimeter I divided it in six into, let me check, I divided those pulses, right, the 48 pulses, in 3, so 3 phases, right, and that was 16. So those 16 uh, what the fuck I did. Okay, I'm not sure for now. Sorry. Let me see. Yes, if there are 48 pulses, then there have to be all imaged or figuring in each rotation of the slasher controller, right? So I suppose there are 16 open and there are 32 closed for each phase. So because each phase for each rotation it's acting a third of the timing, right? For each rotation each phase acts one third of the whole rotation. So 16 pulses open and 32 pulses the same phase is closed. That you have to extend it to the other two phases. So when the first one is open, the other one has to be slightly turned in shape, right? It's got to be one third beyond, so each phase will contact to sequentially in sequence. When the one is open, one third after the second is open, and one third after the third one is open, and others are closed when there is one of them open. That is uh, the whole thing. So with the numbers of that, thinking that there is the slasher attached to the same shaft, that is the real controller, because let me explain myself. I imagine you can do this with other motor apart from the washing machine motor, doing the slashing, doing the controlling, right? But doing that, I suppose it's just a wrapping managing system, because with each pulse, if they are not attached in the same shaft, the washing machine motor and the slasher controller, you are not sure for each rotation they are synchronized, right? Because is if let's say there's another motor running like the slasher controller, right? And that opens it. So it shoots a signal to the washing machine motor, which it's another shaft. So that pulse will turn the washing machine, right? But for the next, you don't know if there if it passed from each pulse, it may pass it the timing the second one should have be turned on, and then the slasher does the second one, right? What should be the second uh, push, but you are not sure if that first one made the which is the positioning of the wheel. I hope I explain myself, right? But by having the slasher controller on the same shaft, you are making yourself sure. There's no other way. Sorry, let me. I'm not very good at English. Having the slasher controller on the same shaft as the washing machine motor, it's sure that when the gate opens of the sequence of the slasher, it's the same positioning of the washing machine motor rotor, right? So for each timing it will be all in place, but I suppose you can do it both way maybe, but it's more sure, more confident it will work totally properly, uh, or in time, better said, it will work in time if it is on the same shaft. What I suppose so is the thing will be a cylinder of like this diameter, right, of plastic, of those polyamide, nylon, Teflon, Kevlar, whatever, or other shit. And then a plate of copper, right, with many, like a train's path, like the train's rail, right, um, a lot of hole of cavities. uh, let me draw it. It will be something like this. Excuse me. In a plane, it should look like, on a picture, a paper picture, it should look like this, right? Like this. Many holes. Uh, and so that then you wrap it on the plastic, right? Just like you were doing your slasher, but that time you have a lot more. And what the thing will be is to the next one, let's say that is for one face, and the other one should be 1/3 of the distance of, right? So everything, it doesn't matches exactly, sorry, it doesn't matches exactly the same position. Sorry, this picture is awful. They don't have to be exactly the same, on the same position. They have to be slightly apart, 1/3 apart. I think you will figure out exactly what I'm trying to express. This is all the thing. I only have some other results of the calculation I've done. Let's say I found that those pulses per second the Anheim is supposed to manage out because of the RPMs achieved and the pulse of the magnets, right? Because the sensor always will pick up the signal, right? It's just mechanical. I'm thinking that each time the sensor passes through here, from one magnet, one pole, it receives the signal. So if it's the maximum you achieved with it, I'm supposing that is what is managing the Anheim controller. So that's the results of this calculation about the Anheims. What I think so. It's just my asshole opinion. There is, yes, it's 25,600 pulses per minute, or if it counts only half of the pulses, it will be 12,800. And the with with a slasher controller of the size of 4 inches diameter, you will have, if it has 8, sorry, those 16 is divided 48 times, right? That perimeter of the 4 inches diameter cylinder, that perimeter you have to divide it 48 times, as I calculated, and that will give you 6.64 millimeters per pulse. That is the distance each will be open and closed. So if you divide that perimeter of the cylinder 48 times, you get 48 slashes of 6 millimeters, 0.64 millimeters each, right? That's the 48 uh, pieces you get if you divide the cylinder. And if that is enough, or you can go it a larger diameter, because this is very big in diameter. I think it was 300 or so millimeters, so 100 will be this big. You can go it a little more big, maybe even 200, I don't know, that is upon to you, maybe. So the connection, the connection or not connection slice will be a little bigger if it's needed. I don't know, with those carbon connectors you had for the slasher, I don't know if this fits well, but that's up to you for now. And so you that way, I mean, you could introduce the slasher a 300 volt connection from feeding from other generator, like that one you said, 20 amp you were making, or anything other, any other thing you will approve, and it will slash each time those 300 volts to each phase. No other complication, right? No no other thing. And the frequency that this will put out, if there is 48 times divisions into that 4 inches diameter cylinder, will be yeah 16,000. If you, let's say, you move it to 1,000 rpms, I don't know if this construction will be self-looping. Of course, this is not exactly a prime mover. You will have to rotate it first to achieve it to run. And so I've calculated the washing machine motor is turning in first place to 1000 rpm, which is something you can achieve, right? And that way you have 16 pulses per minute and phase. So it will be not like the 25,600 from the Anaheim. Sorry, that not forget about that. That means for the revolutions only, right? It's other thing. Sorry. You will have that pulses, but the thing is, once you run it, you can connect the slasher feeding, so it will keep on going. It will turn up the revolutions instantly, right? Because the feeding will be higher in from the time you will connect it, right? It will be like that transfer switch you were talking about. You can run it with the Anaheim until, let's say, 1000 rpm, or the maximal 1600 rpm or 1500, and then you make the transfer switch plump, and so the 300 volts will be feeding the motor instantly, and it will be a pulse controller and a pulse managed motor, because it will be on and off like the slasher, on and off. So the motor will react like a pulse, right? I'm not sure if how you should have the wiring of the motor, if, as you said, that was connected in a Y connection, right? That's a closed Y connection, and so I don't know if it would be better to have not the three ends of the coils attached together, maybe it would be better to connect them to a other thing. I don't know, shocking. I don't know. Let's say ground, right? I don't know. I think that point will make difference, right? I have something like that from here, right? Instead making it like that, if this connection, so the feeding won't end there. I think that will make a difference also. I think that's all I had to say. I'm sorry. I hope this won't angry you because I didn't show uh, a motor turning, as you say in your description. Do not disturb Gerard if you cannot show a motor turning, right? I can show it to you turning, but it will be rumbling and vibrating all my bolts and nuts right now, so it will be just awful to show that. That's why I didn't show it. I think I need anti-rotor washers, right, for the vibration not to pull up my nuts. So keep my nuts tightened. And that's all. I think this will be a controller for it. I think that's 100% uh, achievable or constructible, right? Is very easy, and that's something you figure out. That the slasher is thing of yours, and I was trying to, I was thinking about the controller, how to make it with vacuum tubes instead of MOSFETs, right? Because I've seen videos of the vacuum tubes under high voltage, thousands of volts, tens of thousands of volts, and they are the fucking high voltage managing components hidden, which nobody fucking knows about them, right? Only those fucker they know. They so stupid. So that's quite hard to make, to find, to handle. It's awful for me at the moment. Those vacuum tubes. I hard if I can put my hands on one. It's other story. Now I'm trying to speak about to tell you about this slasher controller, which will be mechanical, will be totally great. And other thing is that if this has disturbed you, I'm how to say it? I'm able to transfer you $1,000, $2,000, whatever you want, to make the prototype of it, right? Because I haven't got a closed relation with any machinist here. They they treat me like I'm a bitch, right? Like, what the heck this little guy is gonna give us? You know that. You know about that. They don't wanna deal with the little guy. So they almost laughing when I'm asking them for price. They make me this piece. They almost laugh me. They don't respond me. It's a shit. That's why I'm not going to do it. And also I will have to make a fucking shaft to the motor itself to make the test, right? And mount all of them is just an idea. I I think you will find it's um, pretty much pretty good. Uh, so mm, because I think you will make it faster than me. That's why I'm leaving it to you. I will make it if you haven't achieved anything good by better by then. I don't think so. So I think you will get it. You will get it sooner than I. So I think that was pretty much all I had to say. Nothing else here. So if there is anything else to comment or something, make me know. Let's contact, right? And see you soon, man. Catch you later.